Hello guys, welcome back today. So you might have seen the title. It's Python Day 6, final day. So it's not the final day of everything. It's just the final day of the Python basics and what you need to know about Python to get started doing only Python stuff. But then Python, expands into a lot of stuff. So we can go into web dev, we can go into Pygame and start making games. We can go, and the largest part where Python goes is data analytics and data science. So obviously, since I'm a data scientist, I'll go into the data science domain. We'll start with data analysis. We'll then go ahead into machine learning, deep learning, generative AI, LLMs. So we'll do that step by step. Also, I have planned, so since it's the winter arc now, so I'm, quite settled in my job and everything. So I have my content ready to go and I have my timings fixed and I have everything fixed right now. So I'm planning to stream thrice a week and I will try to upload other videos. So in other videos, probably we will have day 1 to 90 mathematics of JEE, some solved JEE mathematics questions. Because I mean, since I love maths, it's a great way for me also to get a refresher on maths because I'm planning to do something in the mathematics field like 1 or 2 years down the line. And also we'll have since I'm also very interested in software development also. So it's been quite some time I've done DSA and I wasn't consistent enough. And every time I leave it in the middle. So this time we'll be starting it and I will do it on stream so that I can be consistent enough. I can do it along with you guys if you want to join in. And that way it could be a good commitment for me also. It would be better and I can also share my knowledge, whatever I know or whatever I have learned or whatever mistakes I have done personally to you. You might find it relatable or educational. So let's not waste much time. Today might not be very long stream, probably 1.5 hours. So last time I did tell about error handling, but apparently my mic was on mute, so my bad. Today we'll just right on go into that part. So what are our common objective for this is try to understand common Python exceptions and error types, and then learn to use try and except block. It's similar to a if else block, but it has a different purpose. So we learn to use try and except block. You use finally and else for cleanup and logic, and we create and release custom exceptions, right? And we practice basic debugging with traceback, PDB, etc. So exception or error types. So when does an error occur? Like when you want to do something but that is not supported or that is not the correct way to do it, that's when an error occurs, right? And that's an exception. So there are some common built-in exceptions in Python. For example, there is value error, which means you have a wrong value type, like you are assigning a string to, you are trying to do a string operation on an integer or an integer operation on a string. So that's a wrong value type, right? You have type error. No, sorry, value error is when you try to convert a string to integer. You cannot convert a string to integer. You cannot typecast. That's when value error. When you try to perform operations of one kind of data on other kind, it's a type error. So wrong type of data. Index error, it's accessing an invalid index in a list. So suppose a list is of length 3 and you're trying to access the index 4 or index 3. So obviously if a length 3 it has the index 0 and 2 and length 3 does not even exist. So when you're trying to go and grab something that does not even exist, so it will throw an error, right? And key error, similar concept to the index error, but in a dictionary that this key does not exist. So you want this key. So that key does not exist. If it does not exist, where will it find it? So that's how it works. Let's see with some examples. So let's say ABC, it's a string, right? So ABC, I'm trying to convert it into an integer. What happens there? See, it gives a very big error in red. If you can see, it gives a value error. And what it says, invalid literal for int with based in ABC. So it's not an integer. It's an invalid literal. It's a string. Similarly, for type error, if we try to add a string with a integer, it says can only concatenate string, not integer into string. So if it's a string, we cannot add a string. We cannot add an integer to a string. We can only add a string to a string. That's what it says. Index error. See, list index out of range. Let me just restart it because I've already ran it once and clear all the outputs. Yeah, that's it. So it says list index out of range. So there is no fifth index, right? So it says list index out of range and it's an index error. Similarly, in dictionary, it's a key error. So what I've said a dictionary with the key name and a value Alice, and I asked to print the value of the key age. So it says there is no key called age. There is no key called age. But if I put a key called age, what will happen then? If I put age is equal to 10, no error. See, it will give 10. But for now, I'll just remove the age part. Just have this. Yeah, so that it gives the error. So this is where try and accept box comes in. As you can realize, what is try and accept? So when we try to do something. If it does not work out, accept it does not works out, then we handle those errors gracefully. Like the try block lets you test code for errors, while accept lets you handle them gracefully. What's the basic syntax? We say try, that's a code that might cause an error, and accept if there is some error, we handle that error. How do we handle that error? So if I give you this thing, it will be very hard for you to understand, right? But if I just give you a print statement that yeah, for example, if I give you like this, let me just okay, but for example, if I just give a print statement that age does not exist, it will be very okay. Okay, there is no age in the dictionary, so I can understand. Let's just see once try and accept, then I'll go back to this previous example. So try number, let's say we input a number. If it's a correct number, like if we are converting it into integer, right? So if we enter a will not be converted into integer. It will give a value error. And if it's a correct number, then we print that, yeah, you have entered this number. But if it's a value error, we say, oops, that was not a valid number. So let's see this in action. Let's say we enter 10. Press OK, you entered 10. But if we enter A, oops, that was not a valid number because it has given value error, right? Similarly, here if I say that try and then use this thing, say try this, accept, accept what will be there for it, it is key error, accept key error, we say print key not found, right? So let's say key not found, or let's say key is not found. See, it's much better if you see this and if you see this. If you are a normal user, if you see this and this is much better. This explains to you much better what it is. If you are a dev, you know how errors work and what errors are meant to do. So that's not a big issue. So that's how try except works. So we can have multiple except blocks. Like there can be multiple kinds of errors, right? So if we have something like this, and it might have a value error. So it's basically now we have only 3-4 types of error in the example. But when you write actual pieces of production code or actual product, so what happens is you can the code can throw multiple kinds of errors in multiple. There are multiple steps in the code. So one step might throw one kind of error, the other step might throw another kind of error. So we use try else except like this. So let's see what will do. So it except value error. So here it's not a value error, it's an index out of range error. So if it's an index error, caught an index error out of range. So it will say caught an index error out of range. We can also have nested try except. So let's see. See, x is int of abc. It's a value error. So it will say invalid conversion to int. But if we have x is int of, suppose, let's just have x equal to int 10. So 10 will convert into integer, right? 10 will convert into an integer. So when we do this, we comment it out and we do this. So it will go into this try block. Since this is, well, this is wrong, right? So this value error has been raised. But since now no value error has been raised, it will go into the next line. Next line is a try block. Try block says result x by 0. Now this is a 0 division error. So it says cannot divide by 0. Now we have two clauses. One is finally, and one is else. What when does else run? Else is running if no exception is there. So we use try except, and if there is no exception, else is running. And finally is running after everything is completed. So try except else after everything is completed. Finally is like a regardless of what happened, finally will run. So it is generally used for cleanup. So suppose you are starting a database, you are running some code, you're catching some exception, and then when in finally generally you close the connection to the database or you close the program. So something like that. That even if it's error or even if it's correct, the finally is something that has to be run. Like regardless of it's a correct code or if it's a wrong code or a good input or a bad input, the finally code has to run. So here it's a integer, enter a number. So let me enter a correct number and let me press OK. Great. So what we have, unless it's a value error, it will go into the else block, right? So it will say, great, you entered num. So I entered 10. Execution is finished. So finally says execution is finished and cleanup can go here. Cleanup can go here. But what happens if I use A? So it will now go to the except block, right? It will now go to the except block. So if I say okay, that was not a number. Yeah, sorry guys, my internet broke off. I think I'm correct. So I'll just go it once again over this. So it's if we enter 10, then it goes into the else block because there is no except is there, right? So when except I mean when the except block is not run, it will go into the else block and says great, you entered 10, and finally will run regardless. So if we say a, so the else block except block will run because that's a value error, right? So that was not a number, but then finally block will run regardless of anything. Finally block will always run. So sometimes we need to all have a custom error. So when do you say that at this point you raise the error? Because if it's like this, we raise the error. So suppose we have a mobile number thing, right? Mobile number input, and we ask the user to give input, and we say that it should be a number. But we also say that if it's a number more than 10 digits in India, if we say if it's a number more than 10 digits, then you should raise an error because our mobile numbers are 10 digits. So how does the computer know? So we say that if it's like this, you raise a mobile number, not can't be greater than 10 error. So this is definition of AB. If B is zero, so if B is zero, if denominator is zero, we raise a zero division error. So let's see if it's we run this and we do this. So when it's a correct one, it returns A by B, right? 10 by 2 is 5.0. But if we comment this out and if we comment uncomment this, see, you cannot divide by zero. Zero division error, you cannot divide by zero. So it has raised an error, right? It has not printed anything, it has raised an error. The initial zero division error, if you see, let me just show you another zero division error without the custom done. 3 by 0. Wait, see, it says division by zero, but since we have raised here, you cannot divide by zero. We have specified that. So it says you cannot divide by zero. And when it says in line 3 in divide a comma b, in line 3 of divide a comma b. Understood? Custom exceptions, we can design our own exceptions, right? So we just have to have a negative number error, error defined on the exception parent class. So we use that error. So we use that error like this. Suppose negative number. If square root, we are calculating a square root, but negative numbers don't have square root, right? So if n less than zero, raise negative number error cannot calculate square root of a negative number like this. We run this. Oh, sorry. For 16, it's 4. But if we do this, what happens? Negative number error cannot calculate square root of a negative number. So similarly, as I told you, for the phone number digits, so def phone number error from the exception class. Exception class. So you can also define like how the error should work, but here we just want to print like, yeah, it's an error. You cannot do this. So we just have to print here. You can also have tracebacks and everything. So you can add multiple things. So it is except sorry, it's class. You can define everything inside that exceptions, but now we are just saying pass. We're saying def check phone number, check phone number of suppose we enter in a number n if n greater than 10. Is phone number error, phone number too long, and print min. Okay, so let's see this. Check phone number, and we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Also, here we use elif len n less than 10. We say phone number to show. Or else we can also write it in one statement like this. If len n not equal to 10, raise phone number error. Phone number must be entered in 10 digits. Better? See, it prints 1, 2, 3, 4, 5, 6. But if we just say 9 digits, see, phone number error is 10. Phone number must be entered in 10 digits. So this is how custom errors work. This topic now what we're getting into debugging. I'll just tell you the basics because nowadays every single IDE you'll be working on, every place you'll be working on comes with a debugger pre-attached, and we generally like 98% of the time we use the IDE debugger because it's much more intuitive, much more easier to use. But still, there is something called PDB or Python debugger, and how it works is tracebacks show where and why an error happened, and reading them helps us pinpoint the exact location of the bug. Like you remember line 6, line 1, these are the traceback. So in line 1, check phone number, that goes into line 6 in check phone number n, define check phone number n, and then in line 6, the error has been raised. So like this. Python debugger insert a breakpoint with import pdb.setTrace. So this is the function. This is the syntax to insert a breakpoint and step through code to inspect variable interactively. So what we do here is we use this. Now it's in IPDB. So it has been stopped. When we say PDB set trace, you can see this green arrow. It has stopped after PDB set trace. Debugger has started, and we now have X. Okay, X is 5. We have Y. Okay, y is 5. And since the result equal to x plus y line has not been run yet, so if we say result, see, result is still not defined. Now, if we say C means continue. See, result is there. We can also use N. Okay, N is for next. So when you use N, okay, see, it goes to the next line. Now, result is defined. So if you say result, okay, so it says 6. After that, we see C means continue, and it gives us 6. So now if we say it's 0, so x is 5, y is 0. Now we say n, okay. So it goes to the next line, we say result. Result must not be there. So for result, there should be a zero division error, right? Oh, sorry. For this line, result is 5. 5 plus 0, 5. Now we go to the next line. Here it should give a zero division error because result by y means 5 by 0. So next line. See, it does not go here. Now I say result. So it is stuck here. See, it is stuck here. You cannot say n. See, we have zero division error. Okay. Here we have zero division error. When we had zero division error, see, here we had zero division error. So when we tried to run it, we had zero division error. So when we try to debug it, we get exactly the step where we had zero division error. So that's it for debugging and error handling. Now we'll take 5 minute break and then we'll go into some interesting features of Python like list comprehension, dictionaries, and RE module, pathlib module, a few modules that are very frequently used, and that will be it for today. I think it will be a 40-minute stream. But yeah, those are very interesting modules. Those are like very regularly used modules, very commonly used module. Next up, we'll have NumPy and Pandas. Those both will be done in one day each, like 1.5 hour, 1.5 hour stream. So it will be probably NumPy will take one day and Pandas will take one day. So that will be for data analysis. Then we'll go to data visualization. That will be Matplotlib, Seamon, S, and uh, a bit of Dash. I mean, not very necessary. So Matplotlib and Seamon will do. And then we'll go ahead into basics of machine learning. So why machine learning? What is machine learning? So that's where we'll start slowly diving into different libraries like deep dive into pandas, then scikit-learn, then slowly after machine learning we'll go into deep learning where we go into TensorFlow, PyTorch, preferably PyTorch because PyTorch is much more intuitive. If you know one of the languages, if you know concept of one of the languages, you just have to learn the syntax of the other. The concept remains the same, the algorithm remains the same, the working methodology remains the same, the pipeline remains the same, the way you clean the data, the way you work on the data remains the same. So that's it. And uh, for the SD thing, if it's not a live stream, then it will be recorded video. So it will be. I'm trying day 1 to 90, so it will probably go live from next week. So that I already have some content created. After that, I'll start doing it live. So day 1 to 90, I'm trying. So with 90 days, we'll at least try to cover basics of arrays, basics of lists, basics of basic maths in programming, arrays, lists, up to at least three we'll try to cover, right? Searching, sorting, what kind of different hashing algorithms are there, what are different data structures like queues, arrays, tracks, right? First in, first out structure, first in, last out structure, FIFO, FILO, last in, first out. So those kind of structures. Then hashing will do a bit of trees will do. And after 90 days, we'll try to break into graphs and the advanced algorithms. Like there is this one algorithm, Dijkstra theorem, if I remember correctly, because I have not gone into myself, have not gone into that depth. So we'll try to break into those. Those will majorly be if it's a 1 hour session, it will more than 1 hour, but if it's a 1 hour session, it will be 15 minutes of or 20 minutes of explanation followed by 16, 40 minutes of raw coding. It's not like I know already the answer, so I'm doing it. It will be I'll be doing it and to along with you. So it might be the first time I've seen that question. So yeah, that will be it. But I will make sure to cover everything. I mean, I have as far as I have studied a bit, I know that Cyber's DSC sheet is very extremely well detailed. So I'll try to cover it. And yeah, that's it for right now. We'll take a 5 minute break and we'll come back. So hi, hello, welcome back. So now we'll get into some advanced Python features. So on my left side, you can see what kind of Python features I'm talking about actually. So first we have comprehensions, we have Lambda functions, we have functional programming tools, decorators, file and OS operations. So file operations basically, and regular expressions. So it will be a very interesting topic. It will be very fast, but it will be a very interesting topic. Let's get into it very quickly. So, so Python provides a concise syntax. So you don't have to write if else long if else's. If you want a concise syntax, so these are called comprehensions. So there are of list comprehensions, set comprehensions, and dictionary comprehensions, and all they also support conditionals and nesting. So up to some point, when you have to just write small if else statements, you can just use conditional or like this. So list comprehension is inside the list, you write x square for x in range 10. So that means every x in range 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything will be x squared and stored in that list. When you print it, we see 0, 1, 4, 9, 16, 25, 36, 49, 64, 81. If you change the range, if you make it 8, see up to 49 it's there. I mean up to 7. Set comprehension also similar, but it removes the duplicates automatically because they are stored in a set, right? So it removes the duplicates automatically. So x square for x in 1, 2, 2, 3, 3, 4, 4. So it will just give 1, 2, 3, 4 their squares. Let's just see 16, 1, 4, 9. These are the unique squares. Dictionary comprehension x is so we don't we can specify both the value and the key. So this is the key value pair. So let's just see. 0 is for 0, 1 is for 1, 2 is 4, 3 is 9, and 4 is 16. So you understand how it works, right? Now let's go with conditional. So x square for x in range 10 only if x is an even number. So if x modulo 2 is 0, only if x is even number. Just print it. So 0, 4, 16, 36, 64. Similarly, we have nested comprehensions. So matrix is I cross j for j in range 3 for I in range 3. So what is happening in each step is for each I in range 3. So it's like a double for loop. So each I in range 3, we have j 1 2 3, and then we print it. See, it's for I 0, we have I cross j. So 0 0 0 for I um for I1 we have 0 1 and 2. So j is 0 here, j is 1 here, j is 2 here. And for I2 we have I cross 0, so 0, I cross 1, so 2, and I cross 2, so 4. So this is what is happening. So it's a double for loop. Similarly, we have lambda function. So these are anonymous functions, right? Small functions, right? So a normal function is written like this: define add equal to x comma y, return x plus y. Then we call. A lambda function is defined as add lambda x. We get lambda x comma y, such that x plus y. So when we say add lambda, it's defined in a single line. We use the lambda keyword. We do the parameters and we write what should be happening inside the function, right? So you can relate to it. So similarly, if we have sorted, so we want a key to sort your words, list of words. So we want a key to sort them. So we use a lambda function that what is the key? So the key is length of the letters. So how we say lambda w. So w is the word and length of w is the output of the function. So input and output of the function. We separate it using a column, right? Functional programming tools, there is something called map. So it applies a particular function to each element of a list or maybe a dictionary. Filter if it keeps the element matching a particular condition. Reduce reduces the sequence to a single variable. Zip it combines iterables. Enumerate it iterates with index. So let's just see them in action. These are some things that you have to see in action just to understand. So let me just import it, then map. So we have numbers 1, 2, 3, 4. Squared will be list map lambda x squared comma numbers. So map, it will map this function to this list. So this function is taking input number and doing it square. So this is the function and this will be mapped. This will be mapped to this number. So if we change the function to just x cube, see the output has changed. Or if we change the numbers to this, see it has changed. So it maps this and then it prints it as a list. Let's go ahead with filter. So filter will use similarly map this and filter it out. Map this and filter it out. As it says, when as the name says, it will map it and filter it out. So it will just give us the even numbers, right? Print it, it will give us only 2 and 4. Okay. So if we say it's odd numbers only, see 1 and 5 will be there. We go now into reduce. So reduce will be, it will be when you see the answer, you will just understand how it has happened. So x comma y, x into y, comma numbers. So what is happening is it is taking the sequence and taking reducing it into one variable until there is one variable left. So first what is happening? First it's taking 1 comma 2 comma 5 comma 1 comma 2 and it's doing x into y. So now we have now the new numbers we have is it's something like, let me just write down here. So first initially we had 1 comma 2 comma 5 comma 4, right? So then after 1 comma 2 has passed, so we have 1 into 2, 1 star 2, 2 comma 5 comma 4. Then we have 2 into 5, so we have 10 comma 4. Then 10 into 4, so we have 40. So this function is iteratively applied until there is a single variable left. So if we just say numbers, define numbers as a new dictionary, numbers equal to 2, 3, 4, 5. So what will be it? So 2 into 3, it will be 6. 6 into 4, it will be 24. 24 into 5, it will be 120. So let's just run it. See, it's 120. So what is happening here is similar. It's happening 2, 3, 4, 5. So 2 into 3 is 6. 6, 4, 5. 6 into 4 is 24 and 5. 24 into 5 is 120. See, it is happening in such a fashion, right? Now we have zip. So zip, it basically like a zip, it combines two things, right? So we have names Alice, Bob, and Charlie, and we have scores 85, 19, and 78. So we combine it. We zip the names with the scores and we print it as a list. So see what comes. Alice and 85, Bob and 90, Charlie and 78. So that's how the zip works. So if we add one more thing called see, Dean does not come because there is no corresponding score for Dean. So if we say Dean has gotten 50, now Dean will also come. So it just matches it one to one. It maps it one to one. So and after that, it stops. And if we say age equal to 10, 20, 30, 40, we say zip. See, it has also zipped it. So it just combines it. It combines it one to one. Right? Now we have enumerate. So enumerate takes a particular thing and then indexes it. So how does it index it? So for IDX name in enumerate names, it starts at 1. We print the ID and the name. So see, 1 is Alice, 2 is Bob, 3 is Charlie, 4 is Dean. And now we have decorator. So function that wrap other functions to add behavior. So when we extensively work in OOPS, you will get to understand why decorator is very important. Right now, these examples might not help you that much. So this is a simple decorator. So we have defined the wrapper and we have returned the wrapper and the function is called logger, right? So at the rate logger, this is how we write a decorator at the rate and the name of the function. Def multiply a comma b, return a comma b. So when multiply is called, this function is also wrapped around multiply. So when multiply is called, see calling multiply, see calling function dot name. So name is multiply with argument and keyword argument. So with argument is 3 comma 4. There is no keyword argument, right? print function return result. So multiply return 12 and this is the actual result, right? Static method and class method. So a bit into it. Static method doesn't take self or CLS as the first argument. It behaves like a regular function inside a class, just namespace within it. Used when the method does not need access outside the instance. So there are multiple methods that need access when you make the object of the class, and then the object needs the access of it. But there are some methods that were only are needed inside the class. So internal working of the class. Class method takes class as the first argument, can access and modify class level states, and often used as alternative to constructor. So when method is independent, we use static method. When we need the class itself, we use class method. So this is example. See static method definition of greet, print hello from static method. So example dot greet, or for example dot greet, we get hello from static method. And create with double, so print object from value. So with 5 we get 5 into 2 and it returns print object of value is 5 star 2. You will not get it this much better when you work in in a project, or better when you work in real life scenarios. Then you will better understand how static methods and class methods are very important. So OS and SHUtil, so these are to interact with the file and the file systems and the operating systems. So how to get the current directory you are working in. Get CWD. So I'm currently working in users, Android GC, Python project, Python from stats, and this is day 6. I'm currently in day 6. So if I go to day 5, suppose if I go to day 5 and just give me a second. If I go to day 5 and paste this text in some of here, I'll just paste it here. See, it is day 5 file IO. I'm in day 5 file IO. Current directory is day 5 file IO. Right, day 5 file IO. This is my current directory. I'll not obviously keep it. I'll delete it, and now I'll go back to the advanced features. So what are the files inside this directory? We need to know that I'm in a directory. Directory will have multiple folder. Basically, a directory is a folder, right? A folder in a particular space, and I will need to have multiple files inside it. So these are the files inside it. So .ds store is something common to Macs. We have day 6 advanced features IPNB. So day 6 advanced features IPNB, and day 6 error IPNB. So error IPNB. Let's just rename it to error factoring. Error handling, right? Rename it to error handling. So we make a new folder. Let's make a demo folder. So it is if not os.path.exist. So os.path. So if there is a path that exists, so if there is a folder that already exists, it will not go into the loop. But if not, then it will make a folder called demo folder. So it's not reflecting because, well, PC is slow probably. Let's just do this also. So we have opened inside demo folder a sample.txt file, right? A sample.txt file. If we now currently get the CWD, we'll be why are we not in demo folder? Okay. We can also copy using shutil.copy. So, and after that, we can clean the whole folder structure using shutil.rm3. I'm not running it currently, so I'm just waiting when it pops up in my Python, PyCharm ID, so that I can show you. List directory. See, there is in list directory there is demo folder, right? So if we use dot slash demo folder, inside demo folder we have copy.txt, we have sample.txt, right? Uh, Now we go ahead to regular expressions. So what is regular expressions? Here I'll just use this thing. Else, well, we will be running it. So it helps in pattern matching. So there will be patterns in your text, and it helps in pattern matching. So re.match start from the beginning. Re.search it matches anywhere in the string. Re.find all it does all the matches, and re.sub does replacing. Let's just see. So we have Let's say we have this text. Just so we imported the RE module. We have this text. RE is a very powerful tool, guys. When you do data analysis, RE is one of the most very rigorously used tools. So contact us at support@example.com or sales@example.org. Now, this is how we write a regular expression. So this is what we're trying to match. So this is the email address we're trying to match. On this, I'll do a separate video on this. So this is the email address we're trying to match. So see, it has only given us the email addresses. If we search for support, right, and we find, if we search, we try to get where it's found it. So we use the match thing. So it is found at index 14. So let's check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15th character will always be at 14 because of zero-based indexing. And if you want to replace it, so we replace @example/.com with hidden.com. So example.com or example.org, right? Com or org will be replaced by hidden.com. So we print it and we get contact us as support at hidden.com or sales at hidden.com. So on RE, I will do a separate video. I will do a half an hour video and I will upload it. You don't have to worry about RE. So if you want to skip RE for now, you can do that. And I don't think anyone is in the chat. If anyone is in the chat, a hi would be appreciated. Or maybe you can ask your queries if you have any from today's session, or I'll just end it in like 5 10 minutes. See, demo folder is now here. We can open copy.txt and we can open sample.txt. Now, when we do shutil.rm tree, shutil.rm tree, the whole tree will be removed. The whole directory structure will be removed. So demo folder will be removed in some time. So I don't know how long. Okay, that's it for today, guys. So goodbye, guys. Have a nice day. Have a nice Tuesday. Mangalwar. Peace.